Hi, my name is Bruno Hernandez, and this is one of the pre-crowd questions. So here it says, a pendulum hangs from the ceiling and swings back and forth towards the wall. And research timing at a t 4 seconds. 4 seconds when the pendulum is closest to the wall, 25 centimeters away. So that indicates that our starting point is at 4 seconds and at 25 centimeters away, which is our minimum is 25 seconds. 3 seconds later, the pendulum is furthest from the wall, 83 centimeters away, which is our max. So now, find the equation for the distance the pendulum is from the wall at any time t. So first, we have to write down the equation. Okay, so when doing so, we can make a graph. So we know that our minimum is 25 centimeters and our max is 83 centimeters. So we know that our starting point is at 4 seconds. 4 seconds. So now we know that the starting point is here at 4, and at 3 seconds, it's a maximum. Now for us to go back to our minimum, we will have to do another 3 seconds. So it's 3 seconds plus 3 seconds, which indicates our period equals 6 seconds. So now the formula for in order to find b, it's b equals 2 pi over p. So if we do it down, it's 2b equals 2 pi over 6 seconds. So when we do it, we have to divide, which we get, which is our b. So now we can check that out. Now we know that here in the equation it indicates where it says that our Henry starts at his 4 seconds, which means it's a vertical, which is a horizontal shift, which is here for h. So now we can write down, so now we have to find our midline. Now in order to find our midline, we have to get our max, and subtract it by our mid. When doing so, you could divide it by 2, which will give you 58. When getting 58 divided by 2, divided by 2, and then you get 29 when doing this part of the problem. Will give you our amplitude, which equals 29. Now you can, this is your own decision. You can use you could use sine or cosine, whichever one, but in this problem I decided to use cosine. So now that we have our amplitude, all we have to do is find our k. So our k is our midline. So when having 29 as our amplitude, all we have to do is subtract our max minus our amplitude, and that will give us our midline, and our midline is 54 centimeters. So now that we have found our K, which equals 54 centimeters, now we could write down, we can actually draw our equation, which would be, so since it's going up, I would do a negative 29 cosine parentheses. And remember, if you guys are doing it in the calculator, you guys have to put the parentheses for it to be, because it has to be separated from x minus h. So it'd be pi over 3 parentheses again, x minus 4 parentheses to close that up, plus 54. Now this is my equation for this problem. So now that we have found our equation, now we can graph it and plot our 5 points. So now this is 0. Now our minimum is 25 centimeters, and our max is 83 centimeters. Oh, pardon me, let me do this again, because this is very horrible. Let me give myself some more space. So now we start here, go that way. Now, let me this line a little bigger. Now, our midline is 25 centimeters. Our minimum, our midline is 54 centimeters. And our max is 83 centimeters. So when doing so, now we can actually plot our graphs. Now, here is our starting point, which is 4 seconds, which indicates time, and this, which indicates distance from the wall. So our starting point is, we make the line. Starting point is right here. We are starting to go up, and we have hit our max. Now we're going, which this has done 3 seconds, and now we are going down again and doing another 3 seconds, which completes our period. So now our the middle, where the max point is at 7. Plus 4 plus 3 is 7, and then 7 plus 3 is 10. So now we do, let me make my cosine a little better. I'm sorry again, I'm really good at drawing curvy lines. So now that that's done, we can actually put our middle one, so which is 8. This one could be 6. Our point could be here. Another point could be here. If we were 25. This will be 6 and 68.5. Our max would be 783. Our fourth point could be 868.5. And our last point could be 10 to 25. So now that we have demonstrated 5 different points, now now that we have found the equation, if you guys want to make sure if these are correct, you could plug it into your scientific calculator, to your graphing calculator, and put in this formula right here as y equals, and then when doing so, you can click on graph and it will show you the graph. Make sure that your windows are good on the options, and if you want to check if these numbers are correct, you could press second graph, or where it says trace on your calculator. And when doing so, you could plug in, for example, if you can plug in the number which could be 4. You press 4, and it'll say x equals 4, and it'll take you to 4 comma 25. When doing that, now you can do 7. You can do 7, plug in 7, and it will give you your max. Now if you want to keep going, so you could actually see if it actually worked, like so you can actually see that the equation is right. Instead of putting 7, now you can put 10. X equals 10. And if it's 25, if your y is 25, then that means that the equation is correct and that your graph is correct, and all your points are correct. And if you guys want to do more cycles, you guys can do another cycle and still keep going. And if you want to check at any point, like for example in the problem it says you can to find an equation for from the distance of the pendulum is from the wall at any time. So at any time you can just put any x value of any number of the x axis, and it will take you to its location, to its distance from the wall. And yeah, that would be all.